Ragnar. Welcome.
Howdy, y'all.
If you're here to hear about what's going on in placement, you're in the right place. Otherwise, sorry about that.
You're going to hear about it anyway.
Yeah. All right, quick introduction, Eric.
So hey, I'm Eric Freed. I work on Nova, do a lot of stuff on placement. I work for IBM Power. My main charter is making Nova work on Power.
Yeah. And I'm Ed Leaf. I also work at IBM, but in the Linux Technology Center. I've been an OpenStack developer since, well, let's just say a long time. And I have our addresses here if you want to reach us. All right. What we're going to do today is just give you a quick overview of placement and how it works. And we're going to try to demonstrate it using this tool called Gabby. And so we'll give you a little introduction of that too. And we're going to manage a refrigerator with placement. And so just to show that no, it's not for Nova only. And then we'll just recap what we got done in Queens, what we got done and are still working on in Rocky, and what we're going to be doing in the future.
All right, so generally speaking, placement is a service that manages resources, right? And any resources, we really don't care. And I'm going to kind of call back to the resources that we manage in Nova as we go through this, but as you see, the example is much more generic than that. So mainly we have the concept of a resource provider. That's just anything that has resources associated with it. So in the Nova context, it's your host. It has the resources that it has are vCPUs, memory, disk, and so forth, right? And those things are considered to be resource classes. And usually we have a resource class like memory megabyte, right? It's something with a unit associated with it that you could have one of, some discrete count of. The resource provider itself has an inventory of some number of items of those resource classes. And then you can take some number of those and allocate them to any consumer. In the Nova case, the consumer is generally an instance, right? So a little sidetrack here. There's a tool called Gabby, and it's a way of running functional tests against an API. It's got some fixture magic going on so that you can issue what look just exactly like HTTP REST requests and get responses in just the same way that you would. You may be used to doing this via curl or whatever. So this is a way to automate that kind of test. It uses YAML files. This second bullet here is the extent of what I know about YAML, and yet somehow I'm able to use Gabby. So it must be fairly easy. And we use it in placement to do this sort of high-level end-to-end testing, right? We can hit the API and do real things with it. So this next section is brought to you courtesy of Chris Dent, who's sitting here in the second row. He put together this repository in GitHub that it does a couple of things, one of which is allows you to sort of deploy a placement service in a Docker container. And then it also allows you to just run stuff against it, right? And one of the examples that he put together is, is one of these Gabby suites that does REST requests and treats the placement service as if it is managing his refrigerator. So we are going to manage Chris's refrigerator in this next set of examples. Hopefully these slides will be available attached to the recording of this, so you'll be able to, these links are all active, you'll be able to go and find this stuff for yourself. That's for those of you desperately taking pictures with your phones as well. So we're going to do a couple of slides. They're going to have some Gabby syntax on them, and then we're going to forget all about that. So as you can see, just simple YAML with indents and stuff. This is the default values that are going to go in every REST request. We put this at the front of the Gabby file, which is called a Gabbit for reasons. Top of this slide here, you can see what a single request looks like. For those of you who are familiar with what an HTTP, what a REST API looks like, this should be fairly intuitive what this is. So I've given my test a name, and then I've said I want to post to a URI called /resource_providers, and then I'm going to put some associate a data payload with it, right? And then below that, you can see this is how it actually translates, how it looks when it goes across the wire, right? It makes this post request. You can see that URI that it expands out. It's got those headers that we associated with it that we put in the defaults in the previous slide. And then this JSON payload that got translated from the corresponding YAML. So in this case, we're going to create a resource provider, right? We're going to call it the fridge. That's how we're going to get started with this, right? So placement responds and says, verily I have created a fridge. And here's the version of the placement API that I did it under. And then here's some links associated with it, right? This is all stuff that you would expect. And the parts that I wanted to highlight here is that it gave you a UUID associated with your provider if you didn't specify one already. And this generation thing, it says generation 0, and we're going to come back to that, right? So now I'm going to start creating some resources in my fridge. Now, placement comes with some standard resource classes, right, like vCPUs and memory, megabytes, and so forth. Anything that's not in the standard set, you have to create custom, right? So first thing we're going to create is lettuce. And the way you do this is with a put, right? And we put to this resource class's URI. And I'm going to create this resource class called custom lettuce leaf. You have to say custom if it's not part of the standard set, just to namespace it out, right? And we get this response. It's a 201. It says, you got it. I'm going to create the same thing. I'm going to get mustard, right? And I have to give it or I'm supposed to, good practice is to give it a unit. So this is a milliliter of mustard because we're metric. Slices of ham, right? And slices of bread. Oh, pickles. We got to have pickles. All right. So far, all I've done is I've said, here are the kinds of things I'm going to put in the fridge, but I haven't actually put anything in the fridge yet. So now I'm going to create an inventory. I'm actually going to stock my fridge. I went to the store and I bought 75 slices of ham and a jar with 25 pickles in it and so forth. So now I put to this URI that says inventories, right? And part of that URI is my resource provider. So I'm going to put this inventory of food into my refrigerator, right? And the response that I get back looks a lot like the request, except that it's expanded some stuff out, right? It defaulted some of these ancillary values onto my inventory for me, and I want to kind of real quick go over a couple of those. So in the processor world, there's the concept of overcommit. If you want to be able to overcommit your ham, you would have set your allocation ratio. Maybe it's strong ham, I don't know. Maybe it's really salty, I don't know. You can set your allocation ratio to something other than 1, right? And then you have the overcommit. The total is the number that we fed in there. Maybe you know that you have to save a couple slices for your dog, or they'll be hell to pay. So you would set a reserved value, right? Step size and min unit. These are like specifying you can't make a sandwich with just 1 slice of ham. That would be ridiculous. So you would set a min unit of 2. And then a step size of one slice additional to that. Max unit, that defaults to looks like max int.
It's a lot
anyway,
of ham.
It could be a lot of ham. It's potentially a lot of ham. So more than there will be on this stage, hopefully. All right. We did actually set a max unit of lettuce leaf because nobody needs more than 3 pieces of lettuce. Leaves of lettuce on a sandwich, right? So just pointing that out. And then I kind of cut the rest of it out, right? The rest of it looks similar, right? So now I want to ask placement, okay, well, how much of my groceries have I actually used at this point, right? And as expected, it's going to respond and say you used 0, right? I've got zeros all in there. One thing I want to point out here, though, is that after I stocked my fridge, and I didn't put this in red, but after I stocked my fridge, the generation of my resource provider, which is the fridge, right, it bumped up to 1, right, which says now I've made a change to this, right? And this is going to be important for the concept of concurrency, which I'll remember hopefully to talk about a little bit later, right? This in case my wife and I both go to the fridge at the same time. We want to make sure that we don't accidentally run out of pickles or whatever. So this is where this is the money slide right here. So this is where if you're in Nova, this is where you're doing some scheduling, right? There's an API called allocation candidates that says I need a certain number of resources of these various resource classes. Please go and see what is available in my various resource providers. So if I had multiple fridges, this would be going out to my fridges and querying them and saying, do you have enough of all of these resource classes that you could make me a sandwich? So this is what my request looks like. I said, well, I want 2 leaves of lettuce, 1 slice of ham, 2 slices of bread, 3 pickles. And there's this get URI that I send that information to. Placement says, I found one resource provider that can do this because I only made 1 fridge. Okay, but if I had more than 1 fridge, possibly more than one of them would be able to satisfy this request. And what it sends me back is a response that contains this chunk right here called allocation requests. That's a list of these dictionaries that says, in this resource provider, here are the resources that you could get. Now, this is a trivial example, so it basically looks exactly like the request I made. Potentially, resources could be distributed across multiple resource providers in certain ways. And again, potentially I could have more than 1 fridge that I'm associated with here. So this list might end up having more than 1 entry in it. And the important thing about this dictionary that I got back here is that it's in a form that I don't even need to introspect it. I don't need to look at it. I can take that chunk and send it back down to the next API that we're going to look at, and it will actually claim that food for me. Right? Now the next part, maybe I've got 2 fridges and I want to make decisions based on which one of those. After I've done this, I want to make decisions based on which one of those fridges I want to actually get my stuff from. So the next part of the response here is summaries of my providers. It actually tells me things about my fridge. Right? In this case, it's telling me all the stuff that I have in it and how much of that stuff is used. So let's say I want to use up everything from 1 fridge first before I move on to the next fridge. That would be a decision that I could use this information to help me make, right, as an example. Or perhaps my fridge tells me how old the food is in it, right, and I want to use the oldest food first, right. So now I'm going to use that chunk, right, and I'm going to put to this allocations API, and it's going to say, I'm going to make a sandwich now, right. I don't need to have looked at that chunk that, as I said, right, I can just take that, and if you look at this, because you memorized the other slide, you recognize that this is the same exact JSON blob that I just sent back into it. And if all goes well, and there's still somebody else didn't come in and claim, too many resources in the meantime, I get a 204 saying, you got it, that's been claimed. So now I'm going to go back and say, show me that resource provider again. Right, and it's going to send me back all of those same links. I cut them out of the middle, but then it's also going to say generation is 2. Right, I made an allocation against my resource provider, and so it has changed and it has a new generation. I'll take a little tangent here to say if more than one of us is hitting the fridge at the same time, and I say I want to I'm stocking it while somebody else is taking stuff out, right? And we make 2 requests at the same time, I need to say what generation I think their fridge is at when I start putting stuff into it or taking stuff out of it. And if I get that wrong, placement's going to say 409 conflict. You need to go re-query the state of the fridge before you make your change again, and then resubmit your request. Right? And that's how we deal with concurrency here. So now if I do this usage request again, you can see now that I've actually got some non-zeros here, and of course these numbers correspond to exactly the allocation that I made. And as you make more allocations, these numbers go up accordingly. So that's the end of the fridge example. There's obviously a lot more corner cases and details that we can go into. I only did it with 1 fridge. I only did it with one. With a handful of resources, with 1 kind of request. What we'll kind of get into from this point on, we may be able to go off into some tangents and get into some of those details as we go. So, hand it over to Ed.
Okay. Anyone hungry yet? Oh, okay. All right. So I want to recap what the placement team has gotten done and what we're working on and going to get done. Some of these, I should just say, they're more like internal housekeeping things, like we realized we forgot to do this, so we made a change. We have, placement uses microversions, so anytime we do anything that changes either the way you request something or the response you get back, we bump the microversion. So in this case, we had changed in a previous microversion what we return when we get the usages. The project ID and user ID were added. However, the API, when you put those in there, didn't have it. So they didn't mesh very well. So we just cleaned that up a little. One thing we ran into was when we're doing a migration. See, typically in Nova, the consumer of resources is an instance. When you're doing a migration, you have to allocate against the target host while you still are using up resources on the source host. So you kind of double up the allocations there. In order to keep track of that, we use the migration as the consumer on that one. But we wanted to be able to, when the migration either succeeds or rolls back, to clean both of those up in one atomic operation. The way the API for allocations is you could only set one consumer at a time. So we changed it. We added a post method that can accept multiple consumers. So now migrations are a whole lot cleaner than they used to be. All right, this is the first of several that you'll see that have to do with the concept of nested providers. Eric's example was a very basic resource provider. It had all the resources in it. Real world computers and hardware tend to be a little more complex. So you could have, for instance, a compute node would have a PCI card which has multiple virtual functions. You could have more than one PCI card. One could be public and private. So we need a way to be able to say exactly which provider is providing the requested resources. So this whole concept we refer to as nested resource providers. So for the resource records now, we needed a way to link providers together. So we have two new fields in there. The parent provider UUID is what you would imagine. It's the one that it's attached to. And the root is for when you have multiple levels of nesting. So you can go directly from any level to the root. And you find out, so even if you're looking at a nested card somewhere in there, you can say, okay, that belongs to this compute node. So those two were added into the responses. One other thing we found out was that caching didn't work very well. People were getting stale information, and it's because we had omitted cache control headers, so we cleaned that up. The other thing is that let's say you requested a very small VM. Well, if you have a large deployment, chances are pretty much any of your compute nodes could satisfy that if your cloud's not very full. So you could get back a big honking list. And so for performance reasons, we added a limit query parameter so that when you request allocation candidates, you can not get back more than you could possibly use. And that's configurable. The other part about that is that since this is a database query that generates the matches, generally, they would appear in the same order if you had multiple requests for that same flavor of VM. So you would get the same ones back, and that would tend to promote a packing way of creating your cloud, so that the VMs would tend to be in the fill-up hosts first before they start to go to another one. So there's a configuration option that you can set that will randomize the list, so that will tend to spread them across hosts. Okay, traits. Traits are the qualitative side of resources. So like with a disk, you care about how many gigabytes you're consuming from that disk for that particular instance. But you can have different kinds of disk. You can have spinning disk or solid state. So one of the things you can do is label a particular disk provider with traits that say solid state or spinning. And then in the request, you can request If I definitely want solid state, I can put that in the request and I'll only get back disks that match that. So these are filtering by traits. And all of these are already in the documentation. There's a link there at the bottom, and you can read a little more detail on all of those. Okay, so we started in with Rocky, and we realized we have two main APIs that have to do with getting back information about resource providers. There's the standard get/resource providers, and that just gives you back the provider itself. The other one is get/allocation candidates, and that returns the resource providers plus those blobs that Eric referred to that you would use if you subsequently wanted to claim those resources. They're kind of the same, and we really want to keep the two APIs consistent with each other because they're kind of doing the same thing. So we didn't have this completed in Queens, but so it was like one of the first things we added in Rocky. So traits are, regular resource providers are filterable by traits. So Eric also mentioned the whole idea of resource provider generation to detect conflicts for race conditions and things like that. An oversight is we didn't have that get updated and checked for conflicts when you change whether a resource provider was added to or removed from an aggregate.
Should probably mention what aggregates are.
What?
Probably mention what aggregates are.
Everyone know what aggregates are?
What they aren't.
Okay, it's just a way of associating compute nodes, different hosts together to say these are all to be treated as having something in common.
Ed, is this the same as a host aggregate? Is this the same as a host aggregate?
No, but its placement aggregates are also separate from Nova aggregates and host aggregates, so I don't want to get too much into that. The main point is that when you do change an aggregate in placement, you associate or dissociate a host with an aggregate, that could affect the results that you get with filtering. So we made sure that we have generation checking and increments for aggregate changes. Okay, the thing with the generations is they start at 0 when a resource provider is created, and then every time you make a change, it increments by 1. It was felt that was kind of an implementation detail, like of the API leaking out, and people might inadvertently start to rely on that and act as though that's part of the API contract. And it isn't. It's just, it could be a random number. There's no reason that it has to start at 0. We're just, that's what we're used to. So now when you post a resource provider, you get back the copy of that resource provider, including its generation. So that this way, you don't have to assume anything. If we decided to change it to random numbers under the hood, it'll still work for the client because they're just using what they get back. There's no assumptions being made. Okay, now the other thing we had filtering by traits added in Queens. Now we're filtering by aggregate membership. So you're now able to say that I want something that meets all these resources, and the resource provider is a member of one or more aggregates. So it's just another way of reducing the amount of filtering that has to happen client side. There's, that's done now in the Nova scheduler. Now it can be done directly in placement. All right, this is the one that I like, forbidden traits. It kind of has a taboo feeling to it. All it really is just saying the opposite of what trait filtering is. So in other words, when I say I want an SSD, that's pretty straightforward. There wasn't a way to say, okay, for this flavor, as long as it has enough disk, but don't use up SSDs for this one. This one's a lower price or whatever. So we have just basically it's a not in the SQL, but forbidden traits just sounds so much nicer. We also cleaned up, or we're starting to. We have a lot of, there's only so many HTTP response codes that exist for figuring out what went wrong. So we have a lot that raise a 409. So the addition of error codes in the response JSON will enable people to understand better what went wrong exactly. So as we're adding new features and new changes, we're making sure we're kind of enforcing that, yes, you update the error code to be something unique for that particular condition. And this is also tied to the nested providers. They're granular resource requests. And what we mean by that is, originally, if you just say, give me something and it has to have these traits, as long as one of the providers in that mix has that trait, it passes. You may want to say that I want this particular resource to have that trait. And in a nested situation, that could be critical. So we changed the way you can request it. By default, it just works the way it has since we added traits, but now we can specify traits by numbering the resources as in the request. So that's what has merged so far.
Or at least when you wrote the slides.
Oh, really?
Yeah, I think we've
Did this one merge?
I think we've got a little bit more.
Okay. Well, the general concept of nested providers, we've been laying the groundwork for it and all the pieces that are required. The last little bit was returning the nested structure in the allocation candidates, being able to post them from the Nova side, and figuring out exactly how to implement the building of those resources. So it's really close. I mean, that's why I thought this is what Eric was referring to. The patches for it are already up and under review, and so this should, if it hasn't finished merging, it should merge very soon. Consumer generations. This is similar to the resource provider generation. It's a way of detecting race conditions. And this is necessary because we want to move to a model where Nova isn't proxying for every other service. So when you're building an instance, maybe you have a resource, a bandwidth that Neutron controls. When you put the allocations, though, you're putting a complete set of the allocations for that consumer. So if, let's say, Nova's allocating and Neutron's allocating, whoever comes in second will wipe out the first one's allocations. Obviously not a good thing to have, so consumers now have generations. And in that case, whoever comes in second will get a 409 conflict response, and it's up to them at that point to then requery the state of the allocations for that consumer, and then based on whatever the particular logic is, either combine theirs with what they get back and resubmit it with the new generation, or just throw up their hands and say, oh, sorry, something's wrong. At least this way we won't get data overwritten. So this one really isn't a placement change, it's more of a Nova change. There's so many cases where we want to filter on Nova aggregates, but Nova aggregates are not placement aggregates. So there's work underway to, anytime an aggregate changes in Nova, to immediately set the same change in placement. So this way, the traditional filters that we have on the Nova side for the scheduling, based on aggregate membership, will now also work in placement. So that should all get done in Rocky. In the future, we had a session yesterday about this. Placement started as a kind of part of Nova, but all along the idea was just keep it a general resource management system. So we'd like to remove the code into its own repo and set it up as a separate service, separate database, all that. The reason for that is we can kind of focus on the placement side of things, and Nova can focus on the Nova side of things. Also, let us clean our code up a little bit. It's all jammed into a couple of files now. We started that part as a preliminary step in extraction, but we still have a little ways to go. We're working with the Cyborg team. If you're not familiar with them, Cyborg is a system, is a separate OpenStack project for managing accelerators, and that includes GPUs, FPGAs. They have a little bit more complexity than, let's say, some of the other things. They definitely fall into nested resource providers, but they're also dynamically, in the case of FPGA, are dynamically reprogrammable. So how you reflect the resource in placement will change. And the models that we had for Nova, once you deploy a compute node, well, its resources are pretty much static. For Cyborg, the resources it will be managing will not be static in many cases. So we're working with the Cyborg team to make sure that the solution that they have will work smoothly with placement. And again, in the hairy nested resource provider category comes NUMA. We have the idea on how to move this forward. It's just that we really couldn't do anything until the nested resource provider work was complete and fully functional. So in the future, this will be one of our top concerns. Right now, the way we handle NUMA is really kind of hackish and difficult to maintain. So this is something that we're hoping to get cleaned up quite a bit. Another thing that we're going to be doing is using placement for quota management. Again, this is more on not on the placement specifically, but on whatever service wants to manage its quotas. One of the problems that Nova found is that now with the cells system that they have, if you have multiple cells and for whatever reason one cell is unresponsive, and you go to query the usages, you can't get an accurate picture because there could be a lot of resources being used in that unresponsive cell, but the total you get back won't reflect them. So having a single service like placement, we already have that information. So we're going to be coordinating with Nova at first and then with any other project that needs quota management to get that through placement. And if you notice on all of these, I have little links, numbered links on there. Again, if you get the slides, you can click on them and that'll show you either the spec or the code or something that links to the particular issues here. And that's it. So if anyone has any questions, please step up to one of the microphones. I'll be happy to answer them.
Hi. I'm curious if you guys have any goals or test gates around performance or scalability.
In respect to what?
Like API performance or scalability, like how many placements you can do per second or how many fridges you can have.
Yeah, so I mean, a lot of the reason that this whole thing was put together was to solve a lot of the scalability and performance issues in the Nova scheduler. And so far, the preliminary numbers are looking good. We don't have gate jobs that I'm aware of that are tracking metrics or especially that are failing if metrics are poor. We do have Chris. Chris has been taking a lot of this work, kind of off to the side. He's been running benchmarks in mocked up environments of, to varying degrees. And you want to say anything about that? At a microphone?
Yeah, why don't you? Because this is being recorded, so people can hear what you're saying when they're watching this.
So on the performance front, basically, placement's been written from the start to sort of be horizontally scaled as easily as you want. It's basically just a web service in front of a database. So if you want it to scale better, you make more databases and more web services. And right now, the largest deployment that we're aware of is the one at CERN, where they're running 20 different instances of the placement service to support their 7,000 hosts or something like that?
17. I thought it was 14,000.
Yeah, 14, it's in the tens of thousands.
So they have a lot of hosts, and they're doing all right once they got to 20 services. And they did have some initial problems with the way their Apache services, which were fronting placement, were having some troubles. But with some tweaks and things, they got it all worked out. And it's designed in a way so that those kinds of normal solutions to scaling will work.
Okay.
Right, are done mainly via configuration and setup rather than having to go and fix code so far.
Right, yeah. And it's things that are outside of placement's code itself. It's just a web service,
Okay.
I've done some informal stuff with sticking it in a horizontal load balancer in Kubernetes, and it just goes like this when it needs to, and then it shrinks when it needs to, and it's all fine.
Yeah.
Cool.
And in
But it's
the
a good idea to have a gate test. I think
Yeah.
that would be a good thing.
In the CERN's talk yesterday, they gave a lot of the numbers that they got when they transitioned from cells V1 to cells V2, which now uses placement for scheduling. And I think after those initial rough spots that they went through and they adjusted for that 14,000 node deployment, I think they were getting 100 millisecond responses. So that's not too bad. Yeah.
Are there any plans between placement and watcher as far as what goes on with VMs as they do different things?
Yeah, I've been talking to a lot of the watcher people, and the problem with that is that the resources aren't really what watcher's concerned with. Watcher's concerned with other metrics, such as, I don't know, like the temperature in a particular rack or bandwidth, you know, throughput, something that's dynamically changing. What?
Yeah, this would be a good time to mention something that placement's not doing, that it's designed not to do, and that it will never do unless certain people are long dead and cold, which is keeping track of state, like the temperature of your whatever, of your rack or your. Yeah.
Oh,
But,
good. Let's
yeah, but don't tell us you're doing it, because then
Right.
you know we
Yeah,
won't like you anymore.
The main concern that I had been passed to me from Watcher wasn't placement per se. It was more, okay, they made a decision based on whatever criteria they have that they need to move some instances from here to there to rebalance the system. The problem is that they don't have access to the scheduler to say, is this a viable host? Because whatever restrictions were placed on the request, like, you know, certain affinity groups and things like that, will this violate that? They don't know. The only way they have now to do it is to try to move it and then catch the failure when it says, oh, can't do that. So that's more of a Nova thing and I've been trying to propose it, and it's been shot down a few times, to just do like a dry run option. You know, expose a method in the scheduler that they can just do a dry run and say, will this pass? So,
Okay, thanks.
yeah.
Thank you for the talk. I just have a quick question regarding the nasty structure of the placement DB, right? So since you guys are considering extract it out, how about, have you guys considered using NoSQL or those?
Good question.
Yeah.
Yeah, when we were in Dublin at the PTG, and we started talking about these scenarios and how things are connected and linked, it really just brought to mind work that I had played with a little bit on graph databases.
Right.
And so I fired up Neo4j and modeled, you know, having so many resource providers in aggregates with traits and this and quantities, and it was so much simpler. The same query works for a simple compute node versus a multiply nested compute node. So yeah, it's much cleaner code. Once you get, you know, it's tough if, I used to be a SQL DBA, so I tend to think in data, I tend to think in SQL. So it took me a couple of days of playing with this till I could unwrap my brain from the SQL thinking and approach it from a graph point of view. And it worked very well.
Yeah,
And
I mean,
so
instead
yeah,
of consider it as a tree, right? You consider it as sets, right?
I say, what?
You're considering it, instead of a tree, you consider the resources as sets.
Yeah.
Yeah, that way it probably will work better in some scenarios.
Yeah.
Well,
A lot better.
so we have the ability to model things as trees, you know, as a branching directed graph. But there's also the concept of aggregates allows you to put things together in sets that are not directed, right? Not a directed graph. I'm not sure if that's what you're asking, but you have the ability to model either way,
Yeah.
and to make queries against them either way.
Are you thinking sets more in terms of mathematical set?
Yeah, yeah.
Okay. Yeah. Yeah, that would work also, but unfortunately, that's hindsight at this point. So maybe if we ever do extract placement, we could do a branch that uses something other than MySQL and play around and maybe get consensus. And we could keep the APIs the same.
Yeah.
And just work better.
Yeah. Probably give it a try in the future sometime. Yeah. Okay. Thank you.
Great.
Thanks. I think we got one. We probably got time for
Yeah,
one more.
we're at time, but we can do one more.
I had a question in the placement service. Will there be some kind of mechanism to prefer similar flavors to group together to avoid some of like the Tetris holes that start to get created when different flavors kind of start to stack on one compute? You kind of then start to develop these holes that then you're then like not able to fit those larger flavors anymore because maybe like a small flavor then got inside one of your computes that like otherwise could have gone on another one that like it just like would have fit better if they all kind of preferred to stay together. Is there like a mechanism in the placement service to kind of prefer similar flavors to stay on the same compute?
Placement doesn't make choices for you. It just says, here's all the things that can possibly meet what you asked for. So in the Nova scheduler case, it gets back those things, and then it can introspect the host and say, yeah, this one doesn't fit as well as that one. And then that would be a weigher that would sort them in terms of preference.
Point is that happens at above the level of placement.
Mm-hmm.
Placement does the initial filtering, and then you would do that sort of thing afterwards, that kind of fitting
Right.
afterwards.
Sort of build that in by using aggregates. If you had a way of saying like these flavors are all going to go into this aggregate and these are going to go into this other aggregate, and then they're going to stack well.
Mm-hmm. Right.
But it wouldn't be placement being aware of that at all.
Right.
Be aware of the aggregate.
Okay. Thank you very much.
Okay.
So just real quick, there's a couple more slides here that have all the links that we mentioned that were linked in. And then at the back here, we've actually got the main API reference document and the microversion history, which gives you kind of a list of all the features.
Yeah.
Is there a session in here after this? Is there another one after this? Yeah.
Okay, so
We got to wrap it up, but we'd love to take your questions outside the room if you guys want to hang out, and we'll talk to you guys out in the hallway.
Great.
Thanks a lot for coming, everybody.